Section 2.5, page 2. So one of the things that's going to come up in a minute is some terminology with trigonometry, that if you had sine to the fifth x, you could think of that as, sine x to the fifth, or whatever number it may be. So we're using a generically. This works the same thing with the cosine, the tangent, and really all trigonometric functions. So what will happen is if we see something such as like sine squared of x, for taking derivatives, it might be better to think of it as a sine of x squared to help see the nesting function more clearly. Now, it doesn't happen until this third example, but let's build up to it and see how all of these problems that look fairly similar are slightly different. So I've got my y function, so I'm writing my y terminology. Working from the outside in, I see a cosine. The derivative of the cosine is negative the sine. Because it was a cosine of 3x to the fourth, I'm going to have my derivative be of 3x to the fourth. But because my variable here has a derivative beyond 1, I'm going to multiply the 3 with the 4 to get a 12. I'm going to subtract 1 from the 4 to get a 3. And for clarity's sake, we're going to take the 12t cubed, multiplying it with the negative 1, and writing it out front, where the sine of 3t to the fourth is followed by that. Question B looks very similar, except for instead of the 4 exponent being on the t only, it is on the monomial 3t, so a coefficient times t. So again, I see a cosine first, whose derivative is negative the sine. Whatever is in these parentheses is completely duplicated with the sine. But thinking of 3t to the fourth power, and instead of writing it as 81 to the t to the fourth, we're going to say, hey, I've got a 4 exponent outside parentheses. So I'll put the 4 in front of parentheses. I'll subtract 1 from the exponent, and the interior of the parentheses stays the same. But now I can take the derivative of the 3t to get a 3. So again, I have a 4 and a 3 that can be multiplied with the negative sign to give me the negative 12. But I've got 3t cubed versus just a t cubed. And then I've got the sign of the original interior. So these may look somewhat similar with a slight difference based on how the question was asked. But here's where the bigger difference shows up. I have cosine fourth of 3t. So we learned that we can go ahead and put that 4 exponent outside of the entire cosine of 3t. This becomes our outer function. So I'm going to take the exponent of 4 to put it outside my parentheses. I'm going to subtract 1 to get 3. And then this interior of cosine 3t stays in my parenthesis. Now I'm ready to take the derivative of the inside. Starting from the outside of the green, right? First thing I see is a cosine whose derivative is negative the sine. And so I left the interior the same. But now I need to take the derivative of 3t, which is 3. Now I still have a 3 and a 4 and a negative sign that I'm going to multiply to negative 12. All of these had a negative 12. But this cosine of 3t that I had moved the 3 exponent out front, I can move it back to be just above the cosine itself. And we had the sine of 3t. And we're not going to do any trig identities to try to simplify this, especially with the cosine being cubed. But very subtle difference in the questions, and therefore what may feel like subtle differences in all of the answers. And here's another example of problems that may look slightly similar, but again, subtle differences have us solving them a little different. First function, f of x, is the sine of x plus 5x squared. So this is just basic rules. The derivative of the sine is the cosine of x. You could say I'm taking the derivative of the inside, which is 1, but multiplying by 1 doesn't change anything. I've got the derivative of 5x squared to be 10x. There is no interior, so there's nothing further to take a derivative of. Now, when I take this same problem, but instead I think of it with a times in between, and then maybe we write the 5x squared first for clarity, I'm going to have to use a product rule where I think of the first function being 5x squared, and the derivative of product rule starts with the derivative of that, times the second derivative, in our case the sine of x, which is untouched. Because it's the product rule, we're going to add. And then I'm going to take the derivative of the second function, the derivative of sine x is positive cosine x, and multiply it with the original second function, which in our case is 5x. In terms of this problem, other than moving the 5x squared out front, there really is nothing else to simplify. You may be tempted to factor a 5x out of both of these, but we're going to go ahead and leave the answer as is. We weren't instructed to factor, and we want to show how these questions that look similar have answers that look slightly similar. Now, I get to the last problem, C. I see a sign just like I've seen on all of these. I see a 5x squared just like I've seen on the previous two. But notice it's located inside of the sign. So this requires a chain rule. So the derivative of the sine is the cosine, where the interior stays untouched. But now I need to take the derivative of take the derivative of 5x squared, which gives me 10x. And for clarity, we tend to put that out front. Now here's the thing to focus on, right? We're looking at this as f of g. And so we're saying f prime of g times g prime. I have had some students say, oh, I want to take the derivative here and put a 10, and then I want to take the derivative of that and put a 0. Keep in mind, first of all, that would cause our full answer to be 0. But we were looking at this as g, and so g prime is the derivative. The other example I just gave you would have been g double prime times g triple prime, and we only do a single derivative.